In this video, we are going to see few problems based on continuous random variables. I am Dr. G. Lavanya, Assistant Professor, SRM Institute of Science and Technology, Katankarat. A continuous random variable x has the PDF f of x is equal to 3x squared for 0 less than equal to x less than or equal to 1. Find a and b. Find a and b such that number 1, probability of x less than equal to a equal to probability of x greater than a, and secondly probability of x greater than b equal to 0.05. Let us now start with the solution to this problem. What is given here? The first relationship tells us that probability of x less than equal to a is equal to probability of x greater than a. Our entire interval runs from 0 to 1. Now, since the total probability is 1, since the total probability is always 1, we have probability of x less than or equal to a equal to 1 minus probability of x greater than a. In other words, how can we relate this? Total probability is 1 and also probability of x less than equal to a equal to probability of x greater than equal to a. Therefore, by this condition 1, I have my probability of x less than equal to a plus probability of x greater than a equal to 1. Let me now substitute. I will have probability of x come over here less than equal to a is 1 minus probability of x greater than a is probability of x less than equal to a. So these two probabilities together is 1. Hence, the value from these two conditions 1 and 2 will give that x less than equal to a will be equal to x greater than a. So probability of x less than equal to a will be half, and also probability of x greater than a equal to half. And when we add both, we are getting it as 1. Now, when probability of x less than equal to a equal to half, what do we have? This is less than equal to a, therefore this implies integral 0 to a my f of x dx equal to half. Okay, so what is the function here? The function f of x is described to be 3x squared in 0 to 1. So this is equal to integral 0 to a my 3x squared dx equal to half. Therefore, I will have x cube between 0 to a equal to half, because this 1 by 3 and 3 gets cut. This gives me a cube equal to half, or a is equal to 1 by 2 whole power 1 by 3. This is the value of a. Now I have to consider the case when my b x is greater than b. I need to consider the case when my x is greater than b. So what is the case? Probability of x greater than b equal to 0.05. My entire interval is running from 0 to 1. My entire interval is 0 less than equal to x less than 1. So it is greater than b means I will have my b. From b I can run up to 1. B is less than x less than equal to 1. This is my requisite. So this is nothing but equal to integral b to 1. I will have f of x dx equal to 0.05. So integral b to 1, f of x is 3x squared dx equal to 0.05, or this would be x cube between b to 1 is 0.05. This upon simplification will be 1 minus b cube is 0.05, or 0.05 could be rewritten as 1 by 20. Hence, my b cube will be 1 minus 1 by 20, which is going to be 19 by 20. Hence, my b will be 19 by 20 whole power 1 by 3. This will be our answer. Okay, next. Let us go for a much simpler problem with some restrictions. The diameter of an electric cable, the diameter of an electric cable say X is assumed to be a continuous random variable is assumed to be a continuous random variable with PDF probability density function f of x equal to 6x into 1 minus x for 0 less than equal to x less than equal to 1. Check whether it is a PDF. Check that f of x is a PDF. Then, if it is a PDF, determine a number b such that probability of x less than b equal to probability of x greater than b. Okay, probability of x less than b equal to probability of x greater than b. Right. What is the interval that we are considering? 0 to 1. So let us start. So in the interval 0 comma 1, it is a closed interval. In the interval 0 comma 1, always 1 minus 1 is 0, so function becomes 0, otherwise also 0. Always my f of x is positive, rather it is non-negative, is non-negative. Therefore, first I can say that my f of x is now going to be greater than equal to 0. Now, integral 0 to 1 f of x dx is integral 0 to 1 6x into 1 minus x into dx. So we know that integral 0 to 1, 6 is a constant. So x minus x squared of dx. We know integral x power n dx is x to the power of n plus 1 divided by n plus 1. So here it will be x squared by 2 minus x to the power n is 2. So 2 plus 1 is x cube by 3, all between 0 to 1 with a 6 outside. So this is 6 times 1 by 2 minus 1 by 3. So this is 6 into 1 by 6, value equal to 1. Therefore, it is a PDF. Why? Because the value we got is 1. Hence, it is PDF. That is, f of x is the PDF. F of x is the PDF of our random variable x. Now, let us go ahead to prove the second subdivision. What is given? It is given that my probability of x less than b equal to probability of x greater than b. Now look at this. I am running from 0 to 1. I assume b is lying somewhere here. So this portion and this portion from 0 to b and from b to 1. These will be the corresponding for probability of x less than b and probability of x greater than b. So by the given condition, we are having integral 0 to b f of x dx equal to integral b to 1 f of x dx. Am I right? Now this is nothing but 6 times integral 0 to b x into 1 minus x dx equal to 6 times integral b to 1 x into 1 minus x dx. So 6 and 6 will get cut for us. We will have x squared by 2 minus x cubed by 3 all between 0 to b equal to x squared by 2 minus x cubed by 3 all between b to 1. Here upper limit is b squared by 2 minus b cubed by 3. Lower limit becomes 0. Here it is half minus 1 by 3 for the upper limit minus lower limit is minus b squared by 2 minus of minus positive b cubed by 3. So now check what will happen when we resolve. So when you solve this, see what you get. You have a b squared by 2 minus b cubed by 3 on both sides. Bring both to one side. So I will have 2 times b squared by 2 minus b cubed by 3 equal to, from here when it goes here it will be 2 times, 1 by 2 minus 1 by 3 is 1 by 6. So this is equal to 1 by 6, or 3b squared minus 2b cube. 3 into 2 is 6. I have taken LCM. It will go here to give me half. In other words, I will have 6b squared minus 4b cube minus 1 is 0, or 4b cube minus 6b squared plus 1 equal to 0. Let us try to factorize this. If we are to factorize this, we can have 4b cube minus 4b squared minus 2b squared plus 1 equal to 0. I will have 2b squared plus 1 I am having here. So I can have a 2b. So if I take a 2b, I will have 2b squared. I can have 2b squared outside rather. Just check if I am to factorize this. How should I factorize? This could be rewritten as I have 4b cube minus 6b squared plus 1 equal to 0. So when I replace this, I can replace this as 2b minus 1 into 2b squared minus 2b minus 1 equal to 0. So 2b minus 1 equal to 0, or 2b squared minus 2b minus 1 equal to 0. Now you will get, when you solve this, we will have b equal to half, or in other case we are having 2b squared minus 2b minus 1 0, that is b is equal to 2 plus or minus root of b squared minus 4ac by 2a, which gives me b to be 1 plus or minus I by 2. Okay, so we cannot have complex, so we are taking b equal to half. So this is the real value and it has to be considered. Moreover, this lies in our interval 0 comma 1. So this is the solution of the problem. The only thing that you learned here is, when you get values for b, you should have the idea that b is lying in the interval 0 comma 1 and it is a real number, and therefore we have made our right choice, b equal to half. Okay, shall we do one more small problem based on this continuous random variable? Right. If f of x equal to x e power minus x squared by 2, x greater than 0 and 0 otherwise, show that my f of x is a PDF. What do I know? By definition, what does the definition say? Integral minus infinity to infinity f of x dx equal to 1 if my f of x is the probability density function of the random variable x. We just have to check this out. We are not running from minus infinity because the value exists only from 0. Therefore, consider integral minus infinity to infinity f of x dx. It goes from minus infinity to 0 f of x dx plus integral 0 to infinity f of x dx. Here this function value is 0. So this is integral 0 to infinity x e power minus x squared by 2 dx. How am I going to integrate this? Make a small substitution. Put t equal to x squared by 2. Then 2 times dt will be 2x dx. So this would become integral 0 x dx will be dt and I will have e power minus t. When x is 0, obviously t is 0, x is infinity, t is infinity, so it is integral 0 to infinity. So it is e power minus t by minus 1 all between 0 to infinity. E power minus infinity is 0 and e power 0 is 1. So minus 1 by minus 1 value is 1. Hence, therefore f of x is a PDF of the continuous random variable x. Okay. Now, once given your PDF, how to find CDF and some properties of distribution function for a continuous random variable. We shall look into that now. So let us look into properties of PDF. So what are the properties of PDF? The properties of PDF will be number 1, my f of x should be greater than equal to 0. Number 2, integral minus infinity to infinity my fx of x dx equal to 1. Number 3, integral x1 to x2, whether I write fx of x or f of x, it doesn't matter. F of x dx is nothing but my probability of x1 less than x less than equal to x2. Then we also know that x1 less than equal to x less than x2 is also the same as this. Okay, so the fourth property, my probability of x1 less than x less than equal to x2 is the same as the probability of x1 strictly less than x less than x2. I am just recalling these properties. Then after the fourth property, we have our fifth property, my probability of x equal to a, the probability at a particular point equal to 0. So this is very important. Next, we move on to distribution function, CDF. Distribution function of a continuous random variable. So how do I say or talk about distribution function? So let x be a random variable. Let x be a continuous random variable. The function f, that is distribution function, f is defined for all real x. It is defined for all real x. I'm sorry, this is small x, by my f of x equal to probability of x less than or equal to x, where x belongs to minus infinity less than x less than infinity. This is called the distribution function of x. So my f of x will run from integral minus infinity to x, my PDF small f of x dx. This is the formula for the distribution function. Next, properties of distribution function. What will be the properties of the distribution function? Properties of distribution function. So what will be the properties? Now, if x is a random variable that is fixed, okay, and capital F is the distribution function of the random variable capital X, and if I have A strictly less than B, then my probability of A less than X less than equal to B will be f of B minus f of A. The second property, if f is a distribution function of x, then number 1, 0 less than or equal to f of x less than or equal to 1. It should lie in the interval 0 to 1. The second one, your f of x is less than equal to f of y if x is strictly less than y. That is, all distribution functions, that is, all distribution functions are monotonically non-decreasing. They are monotonically non-decreasing, and they lie between and they lie between 0 and 1. This is important. They lie between 0 and 1. Number 3, the third point, your f of minus infinity is limit as x tends to minus infinity of your f of x. We know that f of x has to lie between 0 to 1. So when it is tending to the extreme smaller value, this becomes 0. Similarly, your f of infinity, this is limit as x tends to infinity of f of x. Maximum, that value, it can range only till 1, therefore this value is 1. So these are the three key properties of the distribution function. Thank you for listening. We will continue with few more videos and more problems to illustrate the topic. Thank you.